right, thank you. Yeah, so last year we started on this data engineering roadmap in terms of, what are the main skills somebody needs to have to be a data engineer? And we're kind of slowly working our way through some of this stuff. And in between, we have topics that come up, either somebody has a presentation on something like Spark or something like Airflow. And if not, either myself or anybody here who wants to volunteer, we just find presentations that already exist on these topics and we just talk about it. And the goal is that if you are already a data engineer, to become more versed in general, the actual engineering, the data operations, and the DevOps around data, because that's becomes part of our jobs these days. We've covered ETL frameworks. We've covered things like using Shell for data engineering. We talked a bit about SQL in general, SQL as in relational databases, and maybe we'll come back to it. Sorry, that should not say 1 a.m. And what we're going to talk about today is data catalogs. And data catalogs are, if you don't work for a very, very large company, it's not really a thing. And a lot of people are unaware of what a data catalog is because they're unaware of what a data lake is, meaning they've never had to work with a data lake, which has a lot of stuff in it. But ultimately, data catalogs are a way for folks to discover data in an organization, or in some cases, it's a way for governments or large organizations to expose the data that is available to them. And I'm going to come back to this outline when we get into a discussion. But to start with, we will go ahead and do our standard beginning of the meetup and give shout outs to our sponsors, and also give you an opportunity to introduce yourself and to make any of your own announcements. As I mentioned, we're going to be covering Data Engineers Lunch today, basically open source and cloud data catalogs. There are some commercial ones, which I am aware of, but they tend to be a little, well, not for everybody, but they tend to be out of reach for many of the practitioners, at least I work with. Acqui has been a gracious co-producer of this event. So Acqui, thank you so much for doing all the behind the scenes recording and publishing of the content once we're done with each of these meetups. We'd love to have you be a co-organizer, which is to come and on a recurring basis, maybe bring speakers, or you could be a speaker yourself. Just pick a theme and present on it once a month. Be great. We are part of Data Community DC, which is a diverse community of folks from all backgrounds. And we're always looking for underrepresented communities to speak either on this meetup or any of the other meetups that we have as a family of meetups. There are, I'm guessing, but the overlap of all of the different meetups, I think there's probably 20 to 25,000 unique people across all these meetups are part of Data Community DC. What do we cover here? It's like I like to say, data engineering is about getting your shit together, getting it together, putting it in a bag, and taking it to the store. It's like that Rick and Morty sketch. But really, that is what I think data engineering is about. That's what we cover here. How do you get all the data together? How do you clean it? How do you put it together in a way that is useful for people to use either as APIs or to use it as raw data for exploration, or to be able to look at that information, visualize it, explore it, and even put it into dashboards. Data engineering, also sometimes people talk about data processing, has seen shifts in technology, but for the most part, really what we're talking about is all the different ways we can move data, process data. Could be stream, could be batch, it could be Spark, it could be Flink, it doesn't really matter. But if we were doing this meetup in person, I would ask everybody to just get up and talk to somebody they hadn't known or they haven't been introduced to before. Since we don't get to do that, I'd love to have folks that are new to this group just, show your face if you like, and just introduce yourself, what brings you here, what you would love to learn, or what could you talk about? And if you want to talk about it, I'll put it in the backlog and we'll figure out a time and place to put you on the calendar. So I see, I'm just going on the order that I see on the screen. There's T. Wodros. Do you want to just say hi?
Hi, thank you. It's Theodros. I am new to this group, so I am interested in data analytics, data engineering, and machine learning. So I look forward to learn more in this group and being a positive contributor to the group. Thank you.
Great. Thank you. Nice to hear your voice. I see Alejandro. You want to say hi real quick?
Yes, hello. My name is Alejandro. I'm from Spain, and I'm also working on data analytics also, and I want to learn more because I'm not very experienced yet.
Great. Happy to have you. Let's see, Travis, you may have come before. I'm not that great with names, but if you want to just say hi.
No, I think this is actually my first time. Thought I'd check out the meetup group. I work as a data analytics, data scientist guy at a consulting firm here in DC.
Great. Welcome. Happy to have you here. And Denzel.
Hey, how's it going? Denzel. I don't know if you guys can hear me or not, but I'm a data scientist, or trying to be a data scientist, and I was working on a project where I had to build my database, and I had a lot of fun doing it. So I wanted to dig more into the data engineering side of it, being that that's where we get the data to do anything. So I found this and I joined up. So just want to see what you guys are about.
Great. Happy to have you. Glad you're here. And Nikita, I don't know if this is your first one or this is your second one.
Yeah, this is my first one. I'm a chemist by study, and then more recently been getting into sort of software engineering and Cassandra and data and things of this nature. I've joined Anant a week or two ago. Yeah, happy to be here.
Awesome. Thank you, Nikita. And I see a 571-455 number. If you want to just say hi, or if you aren't new, you can still say hi.
This is Lazy J. I didn't join the participant ID with the phone number. Anyway, you know who I am. But I'll just say to Denzel real quick. I think you're on the right path. For what it's worth, a lot of people who claim to be data scientists are actually doing primarily data engineering in reality. So you're on a good path.
Awesome. Thanks, Jay. All right. So group rules, even during a topic presentation, feel free to ask a question politely. You can put it on the chat. And if I don't notice, you can just say, hey, I'm trying to ask a question. I'm trying to add to the conversation. You're able to ask a question. You're able to just comment on the conversation. It's a conversation, right? Even in a big, 75-person meetup that we've had people have conversations and discussions in the middle of a presentation, because that's what makes it fun. Our company, Anant, we focus on helping customers build, real-time data and analytics platforms. DataStax is a partner. They produce a system that has Cassandra and Spark and Graph. I'm trying to get Confluent to also sponsor us. GW has been a very great partner to the data community in general, and has given us probably event space before COVID every night of the week. And hopefully they will open their doors again. We have some local sponsors. who give us venue space or pay for pizza and soda. And then, of course, our organizational sponsors. These folks, they pay for the bank account, the nonprofit bank account that powers Data Community DC, which then puts on events and trainings throughout the year, like Data Week DC. We did that virtually this year, but it's quite a group of folks and amazing people behind the scenes in Data Community DC. Any announcements from anybody here? Anybody looking for a job, who has a job to offer? Hackathons, conferences, anything that you want to just put a shout out? Okay. We do have some events coming up. So Statistical Seminars has something going on today. I'm not sure exactly why, but if you go to the Statistical Seminars meetup, which I'm bringing up right now. No, it's at 12:30. So you might, if you bug out at 12:30, I won't be offended. SAS graph animation, interesting. What else do we have here? I believe there's a data science. Okay, that happened last week. Sorry about that. And I don't know if we have any events coming up, but let's just see. Nothing new, but always events at Data Community DC. We used to have a feed of different events, but right now I think it's just, you have to click through on each of them. All right. All right, let's go ahead and get started. I promise this is only going to be about 15, 20 minutes and we can get right into the discussion. The presentation that I'm about to show you is something that we prepared in general for a client that was having a challenge. And their challenge was that data catalogs are really expensive if you buy it. There's also data catalogs that you can subscribe to on the cloud. But there's more to data catalogs than just acquiring a data catalog. There's work that goes in and goes into making it. Just like, I hired a data scientist. I want to use machine learning. I'm like, yeah, you got to do other work before you do any machine learning. You got to gather your data first, right? That's what data engineering is all about. This is just a survey. It's not exhaustive, but it's a high-level survey of the open technologies that are out there for making your own data catalog. Some of them have been around for a while. Some of them are new. Some of them were talked about in blog posts and now they're open sourced. But the common thing that you'll see is that almost all of them have like a portal component, and then some of them have a discovery component, and then some of them have a data lineage component. We'll talk about each of those and why that's important. But sorry to say, but open source stuff rarely, until somebody like a DataStax or Confluent or like Red Hat for Linux comes along and puts commercial support behind it, very, very few times you're going to find an open source catalog that does everything for you, which is an opportunity. If you get to know these data catalogs, you can add that to your resume, you can get a job, you can be a contractor, you can even make a product around it. Cloud technologies that are out there, AWS and Google, and there may be others, and I just haven't really spent the time in comparing and contrasting, but AWS and Google's data catalogs are actually based on the Hive Metastore, which runs on Hadoop as well. So you can have your own Hive Metastore on Hadoop. And the Azure data catalog, I'm not sure exactly what it's built on, but I do know that Azure has different data lakes, different generations of data lakes, and there are products that like Synaptics and Databricks and Azure Databricks, Azure Synaptics, and then they have this other thing which is like Spark SQL. But they have stuff like Hive Metastore. Databricks definitely does, but I don't know what their Synaptics toolkit uses. This deck will be put out on the interwebs. I just put the links, that I found while looking for open source data catalogs. And this is a really nice site, by the way, that goes into each, detail of each of these things as a large database of database and database tools. CCAN. CCAN is probably the the first data catalog that I saw. And if you go to CCAN's website, you'll see several websites that are like government websites where the government, like this is the, Singapore government, there's like the Danish government, I think, but they use this for their open data initiatives. And we can take a quick look at it so you get an understanding of what a data catalog portal looks like. And at face value, you can make a data catalog by making a list of all the data that is available in your organization and where to find it. But this case, there's various types of data, and the catalog has APIs to publish the data. So if you're an organization, this is Australian government, Government Canada, if you're an organization with lots of different teams creating data, this is the central place that you can have them come and basically produce or add to the data catalog. Cool thing about CCAN is that there's like 200 extensions. I don't know about what. I'm pretty sure. It's like things for basically discovering different data types, things for visualizing data, profiling data, a lot of cool stuff here. I think you could have like 5 sessions just on CCAN, on how to use CCAN. Cool thing about CCAN is that it can be federated, meaning you can have one CCAN connected to several CCANs. It's really cool. Magda is another one that it's also federated, but it's relatively new. Cool thing about Magda is it's got some tools where it will do a profile of your data. So in this case, it's profiling the data counts over time. And that's part of the discovery and ingestion process. Magda, and you can get architecture diagrams on most data catalogs, but Magda, looking under their hood, what are they using? Well, they have an API, but you're searching through information. That search is powered by Elasticsearch. The registry of all the different data is in Postgres. And as you can see, they have an inventory format that you import your data registry into, and then they have external connectors. So if you're using CCAN, you can just connect it, and then that data becomes searchable here. Clarify something. When you're looking for data in a data catalog, it's not indexing every damn piece of data. Like it's not an enterprise search. It's indexing the table name, the column name, and in some of them they have lineage. So it's like, how is this data coming from where? In commercial products, what it will do is it'll look at a view in like SQL Server, and it'll determine it's powered by 3 other tables, and it'll show you the lineage. Or if it can talk to Oracle reports and basically figure out where the report is getting created from. So anyways, this is one of the ones that I've seen that has a bit of a profiling built in. I think CCAN has similar plugins that you can add onto it. Amundsen is relatively new. It comes out of Lyft. Lyft, as in the competitor to Uber, they have an ingestion framework, and you can see it can take metadata from Presto, Redshift, Hive. You'll see Hive all the time in Spark SQL and Hadoop, and Postgres, and amongst others. You can always add your own data catalogs as long as you use their APIs. Amundsen stores data about the catalog in Elasticsearch and in Neo4j. And that's, a graph is actually really good to understand what the data catalog is, because the data schema might change, right? The data flows might change. And what a graph will do is it'll allow you to look at those relationships without necessarily having to change everything around. And well, a graph database is also a NoSQL database. So it's easy to add new columns, remove new columns, not a problem over time. Cool thing about Amundsen that I liked is that it works with Presto, which itself can talk to various data sources. Cassandra, Mongo, Elasticsearch, Hive itself, and it has its own kind of Hive-based catalog. So it can talk to that and get that metadata. And Presto is a tool I recommend to people anyways. Super cool. Just so you can see when Lyft basically open sourced this, they had analysts and data scientists in mind, as well as data engineers and software engineers, right? And I like their site. They have enough money to hire like a graphic designer, I guess, but it is probably one of the easier ones in terms of getting started. I think you can just like pull up a Docker container, if I read this correctly. But looking at the interface, there's a bunch of different things that are running to make this happen. They use Neptune, which is a Gremlin-based graph database. They use Airflow to basically manage. We talked about Airflow before. They use Airflow to run the scripts that do the ingestion and discovery to figure out the metadata. They use Neo4j for storing that metadata, or they can use Apache Atlas, which we'll talk about. And then finally, they have Elasticsearch for search. I think pretty much all of them use Elasticsearch for search. Let's see, cool interface. It's like built on Material UI. You look for your table and it shows you which columns there are. I don't know if this is profile information or if it's just the age of the data, like what, from when was this data published and how current is it? Let's see, yeah, they do some basic, data statistics as well. Going on to Atlas. Atlas is an Apache project. It's a bit daunting. Basically, you're running Hadoop and you have HDFS as your data lake, and you have tons and tons and tons of JSON or Parquet tables sitting on the data lake. This allows you to go and figure out what that is. So Apache Atlas has a really nice interface. This one seemed to be like harder for me, just looking at the instructions, but somebody might have better luck with it. But then again, like running Hadoop isn't easy. I'm not sure if this natively talks to just Hive on Hadoop, or can it talk to, let's say, Hive on Spark SQL or Hive on Amazon Glue or the Google Data Catalog. But it's considerable amount of work has been put into Apache Atlas. And you can see that because it's not just about storing the data. It has a lineage aspect to it. It has a governance aspect to it. It has data masking, so that when people log in, if they're not supposed to be looking at information or columns, you can set that as permissions. So very robust in the security and governance aspects of the data catalog. Super cool. Their architecture is based on Janus Graph, and they use Solr for their search, and they use HBase for their, so Janus Graph uses HBase or Solr, but Janus Graph can also run on, let's say, Cassandra and Elasticsearch too. So as long as you're running on Janus Graph, you can run on anything that Janus Graph runs on. And then how do you update your stuff? Well, you can either do it via APIs, which is UI allows you to do that, via point and click, but that's just powered by the API. Or you can stream updates to your metadata via Kafka, and it will pretty much, do the same thing. It's just, as you can imagine, right? If you have a lot of different systems creating data, publishing data, probably easier to just send a message to the queue, and you have like an audit log of what's happened. Kylo is one of the ones that looks really cool, but it's got very, well, when I say very limited, it just works with like Hadoop pretty much. And I'm double checking this. Yeah, basically it works with Hadoop and Spark, and that's it, which is cool if that's what you're using. So it doesn't really connect to things like relational databases or other, systems. What it seemed to me is that Kylo was more about a continuous view of what's happening in your data lake as a data lake like enhancement. And it also has a component to do things like to update the metadata. You can use NiFi. So it actually uses Apache NiFi to update itself. And it's got some big players using it. Again, I wouldn't necessarily say this is my go-to if I were to go to it. It's something that I would have to say, you know, is the customer only using Hadoop and Spark? Then it makes sense to at least take a look at this. Still really cool. This is kind of their you know, data lineage view. And then finally, we come to big companies that, well, I guess Lyft is a big company too, but you know, Netflix has a tool called Metacat, and Metacat works with, it actually also works with Cassandra. I don't know why it's not listed here, but it has a discovery engine. It has a catalog that runs off of either, you know, actually uses Elasticsearch, and it uses a relational database. But it can discover stuff from Hive, from MySQL, from Redshift, other relational databases. Metacat doesn't look that refined to me, but it's probably really powerful. If you consider if Netflix is using it, it probably needs to do a lot of work. Cool thing about Metacat is that it looks into all of these different things, including like Pig or Jupyter Notebook, and it can essentially get the metadata from other systems that are using data. And this is really only in the realm of like commercial tools as far as I've seen. So if you have the time and bandwidth, I would say check it out. Is it like ready to roll out for any of our customers? I don't think so, not yet. It doesn't look good. things do get better over time. And then finally, LinkedIn Data Hub. This was, I think, the one, yeah, this is the one that runs on top of Docker. It's really easy to get started. They first wrote about it, just like how LinkedIn has done everything. They wrote about Kafka and then they open sourced it. And they wrote about it and then they eventually open sourced it. It's powered by Kafka, Neo4j, and Elasticsearch in the backend, as well as MySQL. And you know, you have these crawlers, and you can add new crawlers basically to get the metadata and to publish to the Kafka queue, and the rest of it just happens in the background and it gets updated. The common element between all of them are they have some sort of web-based interface to find and look at information. That's the only purely common thing. The other common thing is that it's not a catalog unless it has a registry of the data, right? It's just, they're all implemented differently. So that's number two common, purely common element across all these tools. And the third is that they have some sort of import, export API for updating that metadata, either via a crawler or just by doing API requests or just importing like a CSV. There's not like a standard for it, but at least some of them are proposing that there should be, like CCAN could be a standard. And I don't know exactly what, somebody here may know what data.json is, but this is the first time I've seen data with a capital D.json. Maybe that's like a format to publish information. But that's it, folks. I just wanted to give you all a high-level overview of data catalogs, you know, what is out there, what's open source primarily. And, you know, if anybody does go and like install one of these and wants to show what it can do, love to have you come and talk about it. And with that, I will go back to our general deck here. So open call, has anybody used any of these tools before other than me? Data catalog?
You mean for the data catalog? So we've been using in AWS, the high-based one, the
Glue?
Yeah, Glue.
Gotcha.
Yeah.
And
I mean,
so
it's getting approval in many organizations. Not sure how the approval of the tech stack go, but few of the other friends were saying it was not approved in their form as well. in our firm as well. It was not approved. Recently it got, so we're starting to look into using it.
Gotcha. So it obviously has crawlers for their own data. You'd expect that. What other out-of-the-box crawlers are there that you found useful?
Have not really, like, we did sort of like a POC where we just want some of the repeated stuff that we were doing by code for the glue to take care of, like ETL stuff. So it's still sort of, POC, don't really know all the features it offers, but yeah, I know that it uses Hive in the background. What else? Yeah, and we use EMR a lot. So it very well connected with all the other AWS stack, and that's what the motivation is here. So be it S3 or we want to do something with EMR and then use Glue. All of that is available, and that was the main thing we were looking for. So all the feature-wise, I still have to explore.
Gotcha. It looks like there's some built-in crawlers for the common data formats already. Obviously, it's going to be reading that files it reads from S3, and then the rest of it, it's talking directly. And looks like, yeah, you can basically point it to your Hive DDL statement. It can like figure that out, or you can import existing table definitions. That's interesting. So like if you did an export of your Hive metastore, which you can do, where you can go to Hive and say like, describe this table for me. And you can even do that. And I think you can definitely do that in Spark SQL. But that's cool. Very cool. Anybody else that has used these tools before or something like it? Maybe a homegrown data catalog?
I had unfortunate opportunity to work with CCAN before. This was just prior to the Patent Office project where we first met, Rahul. So I'll just leave it there. Maybe it's much improved. That's a lot of time. But I'll just say this, or rather ask first. In your experience, like out of the perhaps less common capabilities, what would you say is the most important ones in your experience to consider?
Sure. So most important, I think, comes down to what the customer wants, as well as what the need of the business is, which is defined by data scientists, data analysts, and data engineers. So generally, people in technical management, meaning that they manage a group of, let's say that's like they're the CDO, right, Chief Data Office, or they're kind of under the CIO, but they're responsible for keeping people's shit together, basically, in terms of information, but they're not really like a data office. They first come across this either related to enterprise search, or this is a precursor. So basically they're about to do enterprise search and they don't know what data they have, and they have to do enterprise search. And they're like, well, how do I know what data I have? I was like, well, where's your data catalog? We're like, oh, we don't have one. So in both of those cases, like not having a data catalog or not having like a real enterprise search, the question is, where is my information? So having a system that can crawl the existing data sources, get the metadata as much as possible is huge, because then you don't have to like manually, well, and not like the actual manuals. It's like you don't have to go retrofit every one of your data production systems to say, every time I do an update to my data, push this update to this registry, right? That's just one more thing somebody has to do. But if they just produce a database and your thing talks to it and can keep publishing updates to, hey, this data was updated last week or whatever, automatically, that's huge. The second thing I would say people don't know they need it until they absolutely need it is data lineage, which is, where is this data coming from, right? So like, let's say I have a report that gets report database, meaning I go through some Spark process to create some data and put it into Postgres so that data analysts can do some BI visualizations on it. Well, that database could be published every 5 minutes, but it talks to 50 different data sources. And well, that data is only as current as the oldest data that's there, right? So like, let's say one of the jobs failed and it stopped updating data 2 weeks ago. Your data catalog, if it doesn't have a way to do data lineage, wouldn't be able to show you, oh, by the way, your data got updated 5 minutes ago, but it's actually a week old, because potentially some data that would have been useful in crunching this information is old data. And I think the third one is just ease of manageability, right? This is the people problem. Who do I have on staff to deal with this thing? And so let's say, Glue is available on AWS, and it does the 20% of the things that, it does 20, with the 20% of the features of all of these things, it does 80% of the job, which is get it all together, and then somebody's managing it. People are willing to let go of nice features in comparison to, well, how cool is it? Right? How good is the interface? If somebody's managing it, they would rather have that. So those three things, I can tell you off the top of my head, because this is the three things that always come up. How are we discovering the data? How is it connected? And then, where is the software going to run? Hopefully that answers your question.
Yeah, I'm not going to nitpick on those, but I definitely agree with number two, combined with security. U.S. federal, for example, anyone that cares about data integrity, and that's going to be pretty much anyone that's regulated with respect to machine learning pipelines, with built on distributed systems, any commercial enterprise grade data system is going to find them in that pigeonhole with some requirements. And knowing what set of transformations all that data got passed through, and like you said, some of the points you made about how accurate is it, that all leads to bigger questions down the road when it comes to regulators. Capital One banking, that would be data drift. That's the first. That was one of the first concerns they talked about. Data robot, just coincidence. That's one of the key features for deployment scenarios. I think that's good that that was in your top three. Actually, your first one was, sorry. But hand in hand with security, which would give you a different picture for federal and certain industries, if cell level security is required, it's pretty good that it would be pretty good if the catalog system honored that.
Yeah, and that's where the commercial vendors, and there's a lot of work involved, by the way. There's no magic silver bullet where you like turn on the software and even if you pay for it. Eventually the security part, the governance part is hard. And so some of them, they make it a little bit easier. For example, well, I'm not gonna pimp out any particular product, but there's a product where you connect everything into one layer and everybody accesses the data via that one layer, even though it's got its own Spark SQL or it has its own relational database, because in that middle layer in the data catalog, you can say this group of people with this LDAP organizational unit can do read on only these 4 or 5 columns. So even if the underlying data itself does not have cell level security or row level security, this intermediary system will filter it out. Of course, it takes a lot of resources, but we get what you pay for. You get exactly what you pay for. Other comments on data catalogs?
Yeah, I have a quick question. What factors go into a company choosing which product to use?
Sure. So some of these systems, they're explicitly only going to work with Hadoop and Spark, right? Which not everybody uses, and only the biggest quote data groups in companies use Hadoop, for example. So that all automatically rules out some of these, like, let's say Kylo or Apache Atlas. You just can't use it because you don't have the system that it needs. So that's one end of the spectrum. The other end of the spectrum is it's available on the cloud, like Nirmal was saying, it's on AWS, and you pay for essentially as you use it. So it's worth a try. So just trying it out, you know, there's a saying somebody told me when I first started in technology, there's nothing as permanent as a temporary solution, right? I'm just gonna put this little hack in here. Well, it stays there forever. So the cloud vendors, that's what they're banking on. It's like, oh, this is easy to get started with. So sometimes people just choose that. Now in the middle, it's like, what are the priorities? So what I said earlier was, well, it needs to be able to, you know, crawl the data. It needs to be able to do data lineage, and it needs to be able to run, you know, run easily. On one end of the spectrum, cloud is easier to run, so people just use it. On the other end of the spectrum, the open source stuff like Atlas and Kylo, you don't have Hadoop. It's hard to run, so you don't use it. So in each of those, there's kind of like a decision criteria of, is it hard to use, is it easy to use? Does it have crawlers for my data or not? Right, so CCAN, for example, has a bunch of different plugins. That would be, yes, it has crawlers for my type of data, or it doesn't. And in terms of data lineage is, as I said, and in fact, I should have said crawlers, or no, I should have said being able to run it, the number of existing crawlers for self-discovery, and then lineage. Like lineage is one of those things that until you need it, you don't care. You don't really care. For example, I was showing on here on data.gov, right? This is the US data.gov website. It shows some lineage, but it doesn't show you beyond, you know, what it found. So like, say COVID, right? So let's say COVID, let's say,
Raul, try buying an insurance policy after you actually needed it is sort of the point. It's kind of like akin, what I found at least, it's very much akin to version control systems. Like what were we doing back in the day before we started using Git when we were first experimenting with coding? Well, people are just getting into data engineering, data science. That's like an afterthought, which it's just I get what you're saying, but I would recommend, it depends on like where you want to go with in your career. Is this just an experiment? Is it just a one-off sort of thing? And so yeah, it's a customer. At the end of the day, I suppose, if you're concerned about that, then that's a good perspective.
Yeah, and so the lineage thing, I like that comparison, that it's like source control, right? Like now everybody should use source control because it's free, it's on GitHub. But data lineage allows people who are discovering the data to quickly know if, first of all, the provenance of the data, right? If you're, I'm not a big like antique person, but like, what's that book that recently came out? The Goldfinch, right? It talks about the provenance of a particular painting that that's been missing. Provenance means like what is the authenticity of this thing, right? And so lineage shows you the provenance of the information. Where did it come from? So in this case, we have some provenance information. It tells us that, hey, they got this data from the let's see, San Francisco government, right? And it gives you the exact place to go get it. It even tells you the exact data catalog manifest, for example. So you can be pretty sure that because it's coming from data.gov and because that's coming from sf.gov.org, it's probably good. And by the way, I think sfgov.org actually runs CCAN, right? So then you could actually go there and see where it came from. But in one system, having a lineage of all the information is very useful. Does that answer your question?
Yeah.
Any other questions, comments, ideas about data catalogs, or not about data catalogs? Well, all right. I mean, we don't have to spend all the whole hour together. If there aren't any more questions, let's just take a quick look at the backlog and see what we want to talk about next time. There are a variety of topics in here. I know that we have somebody that's willing to do a talk on Airflow 2.0, which is pretty new. And I think the one that I'm like looking forward to is Apache Airflow with Apache Spark. And if there aren't anything, any other exciting speakers that want to come and speak, what we'll probably do is just continue with the roadmap next week. So we talked about databases. We're in the middle of databases. We talked about relational SQL databases. So next week we would talk about NoSQL databases, which I think we could talk about for about a year, because there's like a billion different NoSQL databases and NoSQL protocols. So I think, yeah, next week, if there aren't any volunteers, or if the person who wants to present on Airflow, we will probably continue with NoSQL. Or unless Jay, you want to do one on Spark.
Well, yeah, I could. So one request though first, that probably take the preference for is if I was going to pick one of these items, is missing. Sorry for the background noise. But the question I would have, like, for any of this is like, what are we doing here? What's the use? Why are we doing all this stuff with data? And for businesses, any use case is to optimize the usefulness of that data, the return, however they're measuring it. In the case of machine learning, its rise, it's not really learning, it's just very much different forms of mathematical optimization methods and algorithms. At the end of the day, has nothing to do with intelligence or learning. Nobody knows what that is yet. But what I would say is that in the case where we have big data in particular, or in any case where one would expect to become big because what they're doing covers a lot of ground, I don't know where that's not the case. So the question is how do you process and build pipelining platforms specifically for these distributed math optimization methods that are becoming a little more robust, a little bit more common. It's a lot more difficult when you're actually doing parallelization of the machine learning algorithms that might be amenable to it. That would be a very interesting topic, given that the reason a lot of people want to get into the ML business or carry the tag is do the projections. I think I saw once 2030, $16 trillion global market value. So everything's going to be pretty much tied to it because they want to optimize, their business process. And then that's what it's all about. And I would love to see others volunteer for this. It's a topic that's not often addressed in public forums, but I would definitely sign up for that.
So what I got out of that was,
as an audience member.
Yeah. What I got out of that was how to optimize the framework / platform for distributed machine learning / math processing. Is that a good stab at the title?
That's right, because the common case that I've seen from for about the last 20 years before it was called data science, that data scientists, or scientists, I should say, actually care about the science and whatever they can run on whatever they have locally. Scalability, distributing the algorithm, that is a whole different animal that they didn't sign up for, don't typically care to sign up for. And inevitably, given that, if you buy what some scientists say, that the universe itself is one giant computer, kind of makes sense in some ways. Yeah, there's potentially a lot of data. And if you want to try to optimize what you're using, locally through your data pipes, that's going to require scaling and in an economical way at some point. So that's why I'm pretty sure that's going to be a huge topic of concern. If it's not in certain circles, it will be, I'm pretty sure. So I would love to hear others' thoughts, but I'd be happy to take a stab at it at some point. Share what I have seen and currently know. Thanks.
Yeah, absolutely. I mean, it's a very relevant I mean, blockchain is available everywhere via Ethereum and Bitcoin and probably 90 different tokens on top of Ethereum. But that's what Ethereum calls itself. It calls itself the world computer, right? Like it's basically doing transactions, distributed transactions via smart contracts on data that is stored on the blockchain. And they ran into a scale problem where they were initially structured like Bitcoin, where every node is essentially, the same and consensus has to happen everywhere, to now having this idea of supernodes that are responsible for, more of the consensus, basically, where there's nodes that don't necessarily have to participate in the consensus. But that's a real world data processing problem, which is when a smart contract runs and it updates information, that smart contract can literally run on any node because it's part of the Ethereum world computer, right? And that's just one way to do distributed. You can't, I wouldn't say you would be doing data processing on Ethereum, but you would maybe potentially do data processing and then you would update the Ethereum blockchain. And then that would get percolated to everybody else, right? So that's an idea via blockchain. Now, I think personally, because I know that there's an overlap of certain technologies in the blockchain world with certain technologies in the Cassandra world. And if you're interested in Cassandra, come and join us Wednesdays at noon. Is that the idea of replicating information alongside with replicating the distribution is ultimately the only way to solve the larger data problem. Because you're always going to have some data that needs to be in different places, whereas other data can be only in the place that it's being computed. And it's kind of the, I would say it's as important, right? Central information that needs to be distributed is as important as distributed information that needs to be calculated. And that's really what the big data challenge that Google went after when they started creating MapReduce. And there's a lot of great ideas out there in terms of how to solve that problem. So if you can show us an example of how to solve it today, practically speaking, can I use it tomorrow is a question, then let's do it.
Well, yeah, you were right on track, Rahul, because remember Edelweiss 3 years ago, the first thing you talked about, the evolution from centralized distributed stores, like Cassandra, for example, to truly decentralized distributed systems that require a different type of authorization with respect to consensus and providing the official record. That was one of the key things that we talked about in terms of using Cassandra as sort of a private subnet for any of the given crypto networks. And in terms of the balance between, say, what you're really going for, ideally a scientist wants to, like back in like the year 2000 or so with Goodyear R&D, the only way to scale from like a Dell workstation to a Cray is, that's still a single instance. That's very expensive, but that's a single machine. Here, there's not that choice. But Microsoft 2 years ago announced the AI global supercomputer, which is a little closer to the type of architecture that's ideal. In fact, they have that in production now at Azure. I was a little surprised where they were at. I checked it out after I was talking to some of their federal data science teams. I would also note, Rahul, that 2 years was right after the significant investment stake they took in a late series round of Mesosphere. And that wasn't the only acquisition they made in that space, where there's what they were buying was really expertise in the space where, they would need to basically build out a global AI supercomputer from scratch. They took the best class that they could find. The second,
we're gonna have to pause on that, Jay, because it's 1 o'clock. We're gonna have to let people off. Everybody, thanks for joining. Come back next week for either how to optimize framework platform for distributed machine learning / math processing, or maybe NoSQL databases. We'll see. Take care, everybody. Have a wonderful week, and I'll see you on the flip side. Bye.
Thank you. Bye.